Hi, now we will be discussing how to join two tables in PySpark using various options. We will be discussing what is a inner join, outer join, left outer, right outer, left semi, anti and cross joins. And we will also understand how to take care of duplicates and same names from two tables. So let's get started. We will start by creating two sample data frames. Here I am creating two data frames, employee and salary. And so employee, it contains the employee ID, the name and the city columns, and salary table, it contains employee ID, salary, and then the department. So as we can notice here, the employee ID, it is the common table between both the data sets, and using the common column only, we normally join tables. And these two data frames, I have also created a temporary view out of those so that we can use them in Spark SQL as well, which we will see step by step. So first of all, let's understand how to do a inner join. So this is our employee data frame and this is our salary data frame. So we are doing employee data frame dot join, and as the argument, it takes three arguments. First, the second data frame which we want to join, on which column we want to join, and how the type of join that we want to use. And then the output we will see here. So here we are using inner join, and what inner join does is it will join the two table only when the IDs are present on both sides. So if we notice here, this 1 2 3 is available here and it is available here as well, and this 4 5 is not available in second table, and 6 7 is not available in first table. So in the output we will get only 1 2 3, which is common in both the tables. So that's how inner join works. And in the output, by default, we will get the columns from both sides. Let's say here the employee ID, which is a common column, and these columns comes from the employee table and these columns come from the salary table. So that's how we get all the columns. And if we want, we can mention the list of columns also that we want in the output using the dot select statement. Then whatever column we mention, those will be coming in the output. So that's how a inner join works. And this same join operation we can do in Spark SQL as well. So in SQL, here I have mentioned the magic command so that it knows that I'm writing a SQL. And this is my employee table or temporary view that I had created in the first cell, like here. So whatever this temporary view I have created, I will be able to use this in the SQL query. So now I'm joining the employee table, and then I'm mentioning it is inner join, the second table, and then we mention on what column we want to join. And here we may notice that we are using alias here, E for employee and S for salary. And here we can mention like the employee ID column from employee shall be equal to the employee ID from the salary table. And in the output, we can mention these names using the alias dot the column name, or we can mention the star as well so that it will select all the columns. So this same thing we can do in SQL as well. So this was our first type of join. Now let's understand what are other types. So next we will understand what is a outer join. So like in inner join, we get only the common records. In outer join, what we get is we get everything, like everything from the left table and everything from the right table. And wherever the records are not present, there we get null. So for example, this 4 and 5 IDs were there in the employee table, not there in the salary table. Similarly, these IDs were there in the salary table and not there in the employee table. So this is how outer join works. So in inner join we got only these three, but in outer join we get everything. So that is the power of outer join. And the same operation we can do in SQL as well. Just instead of inner join, we mention here full outer join. And if you notice, there is this small syntax change. Here we mention outer, but here we need to mention full outer because there are other outer joins also, like left outer, right outer, which we will discuss later. So the syntax, it slightly varies between the PySpark and SQL. And in SQL also we can notice we got the same output here. But in this case, like automatically it did not return the employee ID here, which was there on the right side. And that is because here we have mentioned e.employee ID. And if we mention star, then we will get it, because by default it is checking only on the employee table. Looks like in this case, like we are getting two employee ID columns. So this is a small variation in SQL. So it is not able to combine these two automatically. And as we can see, like here it is getting the employee ID from the second table, and here it is getting from the first table. So this is a slight different behavior in SQL. Next, let's understand the left outer join. So how left outer join works is, it will take all the rows from first table or the left table, and from the right table it will take the rows which are matching. It will put the data there. If those are not matching or those are not present on right side, it will put null there. So that is how left outer join works. And as we can notice, it will not put the rows which are there on the right table and not there on the left table. So it will always have the number of rows equal to the left side table. That's how the left outer join works. And we can do the same in SQL as well using this left outer clause. So we will get the same output here as well. Next, let's understand the right outer join. So it is just opposite of the left outer join. So this time we will get all the rows from right side of the table which are present, and if left side table some rows are not present, those we will get as null here. And here we can notice the same thing, that whatever is there in the left table but not there in the right table, like the IDs 4 and 5, those will not come here because this is the right outer join. And this right outer join we can do in SQL also using the right outer clause here. And here if we want all the employee IDs, then putting a salary.employee ID will be better, because this time all the IDs are there on the right side table. So this is how the right outer join works. Next type of join, it is left semi join. And what left semi join does is, it will take all the rows on the left table which are present on the right side. So it is similar to inner join, but it will not take any of the columns from the right side table. So if you notice here, all the columns here are from the left table only. It did not add any column on the right side. So the purpose of left semi is always to, like let's say, use some kind of filtering operation. Let's say we have one table, and from there we want to keep the records only where the IDs are available in some other table. So for that kind of purpose we use left semi join. So the number of records here are similar to inner join, but we are not getting the additional columns here from the second table. That is the advantage, or a different way we are getting here. And the same thing we can do in SQL as well using the left semi part. And here also we can notice that even though we mention star, we are not getting the right side table columns. And there is a opposite of left semi also, which is called as left NT. And in left NT, what we get is, we get the records which are not there on the right side of the table. Number of columns we get the same, like the same column from the first table, but the number of records we are getting which are not there on the right side. In left semi, we were getting the records which were there on the right side, like 1 to 3. Here in left NT, we are getting the records which are not there on the right side. So this is a different use case here. And the same operation we can do in SQL as well using this left NT join. And we have this left semi and left anti-join, but we don't have right semi and right anti-join. Why? Because if we want to filter out something, we will pick the right table first and then we will put the second table. So we can reverse the tables and then we can use the left anti-joins, and that's how logically also it makes sense. So that is how left anti-joins works. And the next type of join, it is a cross join. And in cross join, we use a different method. Instead of join, we mention cross join, and it takes only one argument, which is the second data frame which we are going to join. It don't need a joining column. And why is that? Because how it works is, it will join each row from one table to each and every row from the second table. So let's say this was the row from one table, and for this one, it is joining all the 1 to 7 from second table. Then 2, it is joining all again 1 to 7. 3, it is joining again 1 to 7. So like that, for each row from one table, it will join it with each row of the second table. And that's why it is not checking any condition, and it is joining everything, and it doesn't need the joining column. So this kind of join we can use whenever we want to explode something. Let's say we have some data, let's say some date wise selling data, and if we want to if we have some, let's say, date range, right? Let's say from this date to this date this much sales was there, from this second date to third date this much sales was there, and if we want to expand that for each and every date, so what we will have is, we will have a second calendar or a date table where the dates are like date 1, date 2, date 3, and we can do a cross join so that for each entry from the left table it will have multiple entries for each and every date. So that is one logical scenario how it can be used, but practically depending on our use case we can use it whenever we want. And similarly, we can do the same thing in SQL as well. So here also simply we need to mention two table or view names separated by cross join. So that's how in SQL also it is very easy. So these are all the main joining types. And while joining, there is something we need to be careful. One is about the duplicates. So if we have duplicate data in our data frame or table, then what will happen is we will get multiple or duplicate outputs also in our data. So for example, if we have ID 1 in first table and second table it has 1 2 3, so this 1 will be joined with that one, and in output also we will get 2 rows instead of 1. So we shall always remove the duplicates using drop duplicate in data frame or distinct in SQL. So here we shall be careful whenever we have duplicates, and whenever we are joining the table, so sometimes we may have the same name of the column in the both table. That time also our code can get confused that after joining from which table it shall pick the column. In that case also we shall use this column renamed method. So we can rename any column before joining also, that is better, or after joining also we can select the column from a particular table and then rename them so that the confusion is not there. So this is how we handle duplicates and the same name columns while joining tables. And in this example we saw how we can join two tables. If in case if we want to join multiple tables in one go, that is also something can be done. So here again we can do dot join and mention another table in the exact same way. So that's how we can do cascading of multiple joins into a single statement also in both PySpark and SQL. So these are all the types of joins that I wanted to explain here. So thank you. Bye bye.